Hi, Algebra 1. This is Lesson 94, Uniform Motion Problems. We've had some of these charts already. This is just going to be a new design because we are likely adding some of our distances together today. Okay, so you're going to need to have your notes nearby from your packet. Then we're going to start with our star question 1. You should recognize some of our names that I've put in here. At 10 a.m., Melanie headed south from the library to her home. At 12 p.m., Sanaya left that same library and headed north for her home. At 3 p.m., Melanie and Sanaya were 352 miles apart. If both girls traveled the same rate as each other, what was their rate? Okay, so the first thing I'm going to do is I'm going to have off to the side an illustration because it's very visual for some of you to figure out what is happening in the scenario. So I'm going to have in the middle here a library. Okay, and then the first thing we found out is that Melanie is heading south from that library. So we're going to have her going that direction. So here's Melanie heading south. And then in addition, we have Sanaya is heading north from that same library. So I'm going to show Sanaya heading the north direction. All right, and then we are told that the distance between them later on, once they get to their destinations, is 352 miles. Okay, so I'm just putting that off to the side for those who'd like to see a visual of what's happening in the problem. Now I'm going to go through and fill out the table with some of the information that we know. I'm going to break down our categories into Sanaya and Melanie. And then we are told a little bit about their timing. Melanie starts at 10 a.m., Sanaya at noon, and then it's at 3 p.m. when we check how far apart they are. So if I were to calculate Melanie's total time, I would go from 10 a.m. to 3 p.m. So I would count from 10 to 3 p.m. is 5 hours. So for Melanie's time, I'm going to put a 5. Okay, and then for Sanaya, she didn't start till noon, but she also stops at 3 p.m., so her full timing is 3 hours. And then you'll also note that it talks about their rate. It says both girls traveled the same rate. Okay, so that means that I can identify them with a letter and make it the same letter for both of them. So I'm going to put an R, designating the rate that they're both going. We don't know what that value is. And as we learned in our previous lesson, rate times time equals distance. So I'm just going to multiply across. For Sanaya, I would have R times 3. That would be 3R. For Melanie, I have R times 5, which is 5R. When I go to create my equation, that's when this part over here, the diagram with the 352 miles, is going to come into effect. So in this case, I don't set my distances equal to each other as I had done in the previous lesson, but I add my distances together. So I'm going to take Sanaya's distance, which we call 3R, plus Melanie's distance, 5R, and add them together to equal their total distance of 352. Okay, so 3R plus 5R add together, and I get 8R equals 352. Then I would divide both sides by 8 to figure out what my rate is. My R is equal to 44. Going back to the problem, the question at hand, the unit that we're using is miles per hour. So I'm going to label that for my rate, and that's my answer. All right, going on to the next question. This time we have star 2, Randall heads from his home to Braylon's at the same time that Braylon leaves his home to go to Randall's. They live 332 yards away from each other. If Randall walks at 65 yards per hour, and it takes 2 hours before they meet between, what is Braylon's walking rate? Okay, this is not the same scenario as the one we did with Sanaya and Melanie leaving the library and going opposite directions. Instead, in this scenario, we have Randall in his house, and we have Braylon in his house. And they are indeed coming toward each other, meeting up somewhere in the middle. And we go back to find that they live 332 yards away from each other. So that means their total distance is 332 yards. Okay, so now I'm going to go to my table and start plugging in some information. I'm going to go ahead and start with my first row is Randall, and my second row is Braylon. Pulling out the next piece of information, I know that Randall walks 65 yards per hour. That is a rate. When you hear 2 units with that per in between, miles per hour, yards per hour, feet per second, please pay attention to that. That is your rate. Okay, so Randall has a rate of 65. We don't know Braylon's rate. That's actually what we're solving for. Okay, so we can just put a variable in there. I'm going to name it B for Braylon. Maybe I'll capitalize so you guys can tell that that's a B. And then the time, it mentions that they're going to take 2 hours in order to meet up in the middle. So my time for both of them is 2 hours. Okay, and then when I do my rate times time equals distance, I'm going to carry that across for Randall. I'm going to do 65 times 2. Okay, and that equals 130. And then Braylon would be B times 2, so I'm going to call that 2B. Now remember, these are not going to be just set equal to each other, and instead we're going to add them together. So we have Randall's distance, 130, plus Braylon's distance is 2B, and it's going to be set equal to that 332 yards. From here, it's just an algebraic equation. We subtract 130 from each side. Okay, so now we have 2B equals 202. And then if you divide both sides by 2, I get B is equal to 101. In the context of this problem, we had identified B as Braylon's rate. So I need to put in his unit for rate. And remember what we had up here was yards per hour. So I can write that yards per hour, and then that's the end of that question. Okay, we're ready to go on to question 3. Here we have Alyssa and Liddy were 400 miles apart from each other. They traveled directly toward each other for 8 hours when they finally met. If Alyssa traveled 20 miles per hour faster than Liddy, what was each of their rates? So this scenario is going to be like Randall and Braylon. They're in 2 different locations. Okay, Alyssa, Liddy, and they are traveling toward each other. That means that we're going to find each of their distances, add them together, and it will get set equal to the 400 miles that they total. Okay, so my first one here, I'm going to just call Alyssa, and then Liddy. Pulling information from the question, Alyssa's rate is given. It says Alyssa traveled 20 miles per hour faster than Liddy. So if I were to give Liddy a variable, I think I'll just call her R rate, then Alyssa is 20 miles per hour faster than that, so that's going to be like R plus 20. Okay, then I go back to see if there's any mention of time. And it says that they travel toward each other for 8 hours. So that is my time. They both are going to have that same 8 for their time. Okay, and again, remember we do rate times time equals distance. Now, Alyssa's might look a little tricky. I'm going to take the 8 out front, and I'm going to remember to distribute it across r plus 20. And then Liddy is just 8r. When I go to write my equation, I am writing it for the two added together. Okay, so I have 8 yet to be distributed to r plus 20 plus Liddy's distance, which was 8r, is equal to 400. I'm going to distribute the 8 across. Okay, so I get 8r plus 160 plus 8r equals 400. And then if I add my 8r plus my 8r, that would give me 16r plus 160 equals 400. I'm going to subtract the 160 to the other side. Okay, so now I have 16r equals 240. And then I will take each side divided by 16 to get r by itself. And I get r equals 15. Now I need to go back and check what the question is asking me. And it does say what is each of their rates. And I just found one rate. I'm going to go back to see who did I identify that rate with. So right here, when r is by itself, that went with Liddy. So I'm going to write off to the side, identifying Liddy as 15, and it looks like my unit is miles per hour. Oops. And then Alyssa is 20 more than that. So I just add 20 to 15. And then for Alyssa, I get 35 miles per hour. So I have 2 answers for that question. All right, that's it for our STAR questions. Now you're going to need to get your textbook out, and we're going to do some of our practice questions from our book. Okay, so first of all, let's figure out what page we're on, which I should have had already. I apologize. Okay, here we go. We're on page 393. 393, and we're looking at our A-B questions in our textbook. An eastbound bus left Ukiah at noon. Computer screen just glitched. Sorry about that. 2 hours later, a westbound bus left the same station. If the buses traveled at the same rate and were 500 kilometers apart at 6 p.m., find the rate of each bus. Okay, I'm going to diagram, for those who are very visual, the scenario that we have going on. So we have a bus stop at a city called Ukiah. Okay, so I'm going to have Ukiah here in the middle. And then the bus that is eastbound means that it's heading this direction, heading east. And then there is also a bus that is westbound, okay, heading this direction. So you'll see the pattern here is that we're going to end up adding our eastbound direction plus our westbound direction to get their total distance of 500. When I go to do this in my chart, I'm going to just label my buses, the east bus and the west bus, and see what information I can pull out of it. So we find that each of the buses travel at the same rate. So I can just call that R for both of them. Okay, and then For the time, we have the eastbound leaves at noon, and we're stopping to check at 6 p.m. So from noon to 6 p.m. is 6 hours. The westbound doesn't leave at noon. It says it left 2 hours later. So that means it left at 2 p.m. and it stops at 6. So from 2 p.m. to 6 p.m., that would be 4 hours. Okay, then we're going to use our rate times time equals distance. So R times 6, I'll call that 6R. R times 4 is 4R. And then recall that we are adding those distances together in order to get the total distance of 500. So I'm going to put 6R plus 4R equals 500. Adding 6R plus 4R together, that's 10R. That equals 500. Divide both sides by 10, and I get R equals 50. Just double check in my question to see is that what we're looking for. And indeed it asks what is the rate of each bus. Okay, so that's going to be kilometers per hour. kph is acceptable for doing that. And they both have that same rate. Moving over to question B. A train starts from Peoria at 2 p.m. and heads for Reedley, 750 kilometers away. At the same time, a train leaves Reedley and heads for Peoria at 85 kilometers per hour. If the trains meet at 5 p.m., what is the rate of the first train? Okay, so in this case, they are coming toward each other. So we have coming from Peoria over here, heading to this direction toward the train that is coming from Reedley. And Reedley is heading the same way over to Peoria. We're also given the information of how far away they are. So 750 kilometers is the distance between the two places. Going up to my chart, they called this one Train 1 and this one Train 2. So you could label it like that. Train 1 and Train 2. We do know the rate of one of those trains. That is Train 2, heading from Reedley to Peoria, goes 85 kilometers per hour. But we don't know the rate of Train 1. So I'm just going to put in here a variable to say I don't know what that rate is. As far as the time, they start at 2 p.m., both of them at the same time. They are checking in at 5 p.m. So from 2 to 5 p.m., that means they both traveled 3 hours. Okay, and then I'm going to do rate times time equals distance multiplying across, so I get 3x for train 1. And then train 2, I'm going to do 3 times 85. And that comes out to 255. All right, I'm going to set up my equation where I add the two train distances together. So that would be 3x plus 255 equals 750. I'm going to subtract 255 from both sides. So I get 3x equals 495. And then I'm going to divide both sides by 3. X equals 165. And then I go back to check what is it that the question asked. And it reads, what is the rate of the first train? Okay, so we got 165. We just need to put in our unit. Remember, since we dealt with kilometers, that we must be doing kilometers per hour. And there is my final answer. Awesome. We're going to go through questions 1 and 2 when we do our live lesson online. Thank you.